For my project, I wanted to demonstrate some important aspects of Snell's law and refraction. I wanted to demonstrate the way that the density of a fluid affects the path of the light beam traveling through it. To do that, I'm going to use a laser and a prism. Prism generally looks like this, but because I need to fill it with fluid, I'm going to be using a vase from IKEA that's rectangular, straight sides, glass, and I'm going to be shining the laser through it and changing the fluid that's inside it. Why a vase from IKEA? Swedish people like science. Okay, not all Swedish people, but I mean, I'm sure they like other stuff like meatballs and cake. I remember that's cake, right? Anyway, on to the experiment. Travels in a straight line. It's, the laser goes through, the laser comes out again on the cardboard behind it. Now I'm going to add some water to the prism, and we're going to see what happens to the spot of light. So now we can definitely see it over here. It has definitely moved. Now we're going to add some sugar to the water. In order to change its depth. So we should observe a slight movement to the right. So, as the sugar settles, we definitely see that it moves a little bit to the right. Water is a lot more dense than air is. Sugar water is only slightly less dense than water. If we were to use honey, the effect would be much more pronounced. Okay, so this is the laser shining from sugar water, and we can definitely observe refraction through here. We can also easily view the laser going through the prism because of the fact that there are particles now. Here's another example of refraction. It's nighttime and I'm looking at a window, but you can see my reflection in the window despite the fact that you can still see through it. Now I'm going to shine a laser through, and people on the other side can see this laser, but you can see that part of it is reflected. When I reach the critical angle, we get little internal reflection. All the light from the laser is being reflected back onto me. When I'm not at the critical angle, I can see the laser being refracted onto the wall.